In this video, we'll assign formal charge to nitrogen. And just to remind you of the definition for formal charge is equal to the number of valence electrons in the free atom minus the number of valence electrons in the bonded atom. Or another way of saying that, formal charge is equal to the number of valence electrons the atom is supposed to have minus the number of valence electrons that the atom actually has in the drawing. So let's assign a formal charge to the nitrogen in this molecule. And remember that each bond represents 2 electrons. So I'm going to draw in the electrons in this bond so it's easier for us to assign a formal charge to the nitrogen. So formal charge is equal to the number of valence electrons that nitrogen is supposed to have. We know that nitrogen is supposed to have 5 valence electrons because of its position on the periodic table. So this is 5. And from that, we subtract the number of valence electrons that nitrogen has in our drawing. So let's go back over here to the dot structure, and let's look at these bonds, right? We know that from this bond here on the left, nitrogen gets 1 of those electrons, and from this bond on the right, nitrogen gets 1 of those electrons and hydrogen gets the other. And same for this nitrogen-hydrogen bond. Nitrogen gets 1 of the electrons and hydrogen gets the other. So how many electrons do we have around nitrogen in our drawing? Let's count them up. This would be 1, 2, 3, and then we have a lone pair of electrons on the nitrogen, so that's 4 and 5. So in our drawing, nitrogen is surrounded by 5 valence electrons. So we put 5 minus 5, which is equal to 0. So nitrogen has a formal charge of 0. Let me go ahead and redraw that. So we had our nitrogen here with our 2 hydrogens and a lone pair of electrons on the nitrogen. And we found the nitrogen to have a formal charge of 0. So we have a pattern, right? Every time that you see nitrogen with 3 bonds, let me draw these in here, 1, 2, 3. So 3 bonds and 1 lone pair of electrons, the formal charge is equal to 0. So when nitrogen has 3 bonds and 1 lone pair of electrons, the formal charge is equal to 0. And sometimes you don't want to draw in lone pairs of electrons, so you could just leave those off. You could just say, all right, well, if I just draw this, right, and you know the formal charge on nitrogen is 0, then it's assumed you also know there's a lone pair of electrons on that nitrogen. So this is just another way of representing the same molecule, leaving off the lone pair, because you should know it's there. Let's look at other examples where nitrogen has a formal charge of 0. All right, so we'll start with the example on the left here. And if we look at this nitrogen and we know it has a formal charge of 0, let's see how many bonds it has. Let's use red here. So here's 1 bond, 2 bonds, and then 3 bonds. So 3 bonds, and with a formal charge of 0, we know there should be a lone pair of electrons on that nitrogen. So you could leave it off, right, and just know it's there, or you could draw them in, right? So I'll go ahead and draw in the lone pair of electrons on the nitrogen. So formal charge of 0. Let's look at the one on the right. So if we assume that nitrogen has a formal charge of 0, let's see how many bonds we have here. So here's 1, 2, and 3. So we have 3 bonds. So we'd still need 1 lone pair of electrons. So if you wanted to show the lone pair of electrons, you could put them in there like that. Notice this gives nitrogen an octet of electrons around it, right? So count those up. Here's 2, 4, 6, and 8. So nitrogen would have an octet. And remember, you could just leave off that lone pair of electrons, and it's assumed, if we know nitrogen has a formal charge of 0, that there is a lone pair, and we just didn't want to take the time to draw them in. Let's assign formal charge to another nitrogen, so down here. All right, so what is the formal charge of nitrogen now? Let's draw in our electrons. So each bond is 2 electrons, so I draw those in there. And the formal charge on nitrogen is equal to the number of valence electrons that nitrogen is supposed to have, which we already know is 5. So we put a 5 in here, and from that we subtract the number of valence electrons that nitrogen actually has in our drawing. So for these bonds, right, hydrogen gets 1 electron and nitrogen gets 1 for each of these bonds. So that allows us to see there are 4 electrons around nitrogen. So here's 1, 2, 3, and 4. So in our drawing, nitrogen only has 4 electrons around it. So this would be 5 minus 4, which gives us a formal charge of plus 1. So it's It's like nitrogen lost a valence electron, right? It's supposed to have 5, and here we see only 4 around it, so it's as if it lost a valence electron, so it's +1 for the formal charge. All right, let me redraw that. So we have our nitrogen with 4 bonds to hydrogen, and the nitrogen has a +1 formal charge. You should recognize this as being the ammonium ion from general chemistry. So this has a formal charge of +1, so we have another pattern to think about here. So let's draw that in. We have 1, 2, 3, 4 bonds, and 0 lone pairs of electrons. So when nitrogen has 4 bonds and 0 lone pairs of electrons, we've already seen the formal charge should be equal to +1. So let's look at some examples where nitrogen has a formal charge of +1. So the example on the left, we can see there are 4 bonds, right? And there are no lone pairs on that nitrogen, so that's a +1 formal charge. Over here on the right, same idea. Here's 1 bond, 2 bond, 3 bonds, and 4 bonds, and no lone pairs, so a +1 formal charge on the nitrogen. All right, finally, one more nitrogen to assign a formal charge to. So let's look at this one. Let's draw in the electrons in the bonds. So here's 2 electrons and here's 2 electrons. What is the formal charge on nitrogen? Formal charge is equal to number of valence electrons nitrogen is supposed to have, which we know is 5. And from that we subtract the number of valence electrons nitrogen actually has in our dot structure. So again, we go over here and we look at this bond and we give 1 electron to nitrogen and 1 electron to the other atom. And over here we give 1 electron to nitrogen and 1 electron to the other atom. And now we have 2 lone pairs of electrons on the nitrogen. So how many is that total? This would be 1, 2, 3, 4, 5, and 6. So 6 electrons around our nitrogen. So 5 minus 6 gives us -1, so a formal charge of -1. Let me go ahead and redraw that so I could draw it out here. So nitrogen with 2 lone pairs of electrons we just found has a formal charge of -1. If I wanted to leave off the lone pairs of electrons, right, I could do that. I could just write NH here and put a -1 formal charge. And because of this pattern, you should know there are 2 lone pairs of electrons on that nitrogen. Let me just clarify the pattern here. All right, the pattern for a formal charge of -1 on nitrogen would be 2 bonds, right? Here are the 2 bonds, and 2 lone pairs of electrons. So when nitrogen has 2 bonds and 2 lone pairs of electrons, nitrogen should have a formal charge of -1. Let's look at some examples of that. So down here we have nitrogen. Right, so here's nitrogen with no lone pairs of electrons drawn in, but you know this nitrogen has a -1 formal charge because it's telling you that right here. How many bonds do we have? Well, here's 1 bond, right, and here's the other bond. So we have our 2 bonds, but we don't have our 2 lone pairs drawn in, so you could just know that they are there, or I'll go ahead and add them in here. So here's 1 lone pair of electrons, and here's the other lone pair of electrons on that nitrogen. Notice that gives that nitrogen an octet of electrons. Over here on the right, let's do the same thing. You know this nitrogen has a -1 formal charge, so you know it must have 2 bonds and 2 lone pairs of electrons. So here we can see, here are the two bonds, right? So that takes care of the 2 bonds part. And if it has a -1 formal charge, it must have 2 lone pairs of electrons. So we could draw in those lone pairs, or we could leave them off, right? Depending on what you're trying to show when you're drawing these out.